Hello and welcome to this third session of AI-900, Microsoft Azure AI Fundamentals. I'm Alexandra, Senior Technical Trainer in Data and AI and AI Course Lead at Microsoft. I hope you have had chance to watch the previous videos in this course, which includes a total of 6 sessions designed to build your AI foundation step by step. Before we dive in, here is a little about me. I have been teaching technology for over 10 years. I speak 5 languages fluently and I have traveled to more than 50 countries. And yes, I have been dancing tango for a decade, which is all about innovation and creativity, just like AI. In this third session, we are stepping into one of the most exciting areas of artificial intelligence, generative AI. This is where machines don't just analyze data, they create. You will learn what generative AI is, how it works, and why it's transforming the way we write, design, and build applications. We'll explore large language models, LLMs, the technology behind tools like ChatGPT and DALL-E, and discover what makes them different from traditional AI models. Then, we'll see how you can harness these models in Azure to create text, images, and even code. And finally, we'll look at AI agents, intelligent systems that can take action on your behalf. By the end of the session, you will understand the core concept of generative AI and know how to start building your own solutions in Azure. So let's get started and explore the world of generative AI and AI agents. This session is divided into 2 parts. First, we'll introduce the core concept of generative AI. Then, we'll show you how to get started with generative AI in Azure. Let's begin by reviewing the key concepts. So what is generative AI? Generative AI is one of the most exciting areas of artificial intelligence because it doesn't just analyze data, it creates something new. Unlike traditional AI, which focuses on predictions or classifications, generative AI produces original content in response to natural language prompts. At the heart of generative AI are large language models, or LLMs. These models are trained on massive amounts of text, books, articles, websites to learn patterns in language. They don't memorize sentences. Instead, they learn how words and phrases relate to each other so they can predict what comes next. This ability allows them to generate text that sounds natural and contextually relevant. Think of a language model as a very advanced autocomplete system. When you type a prompt, "Write a cover letter for my resume," the model predicts the next word, then the next sentence, and so on, building a coherent response based on patterns it learned during training. Generative AI application uses models to create content in different formats. For example, in natural language generation, you might ask, "Give me 3 ideas for a healthy breakfast that includes peppers," or "Write a cover letter for my resume." The model responds with well-structured text that feels like it was written by a human. In image generation, you could say, "Create an image of an elephant eating a burger," or "Design a logo for a florist business," and so on. The AI interprets your words and produces a unique image that matches your vision. And in code generation, developers can ask for help writing software. For instance, we can use a prompt like, "Show me how to code a game of tic-tac-toe in Python," or "Write Python code to add 2 numbers." The model instantly generates functional code, saving time and effort. Generative AI is transforming how we work, helping us write faster, design better, and build smarter applications. Its creativity, powered by technology and language model, are the engine behind it. Language models may sound complex, but understanding their architecture helps you see how they work. Today's large language models are built on the transformer architecture, which completely changed natural language processing. Transformers learn relationship between words by training on massive volume of text. This allows them to predict sequences of words that make sense. So, while their responses often sound human. Here is the big idea. Computers work with numbers, not words. So, we convert words into numeric representations called tokens. Tokens are mapped to embeddings, which are multidimensional numeric vectors that capture meanings. Words with similar meanings have embeddings that point in similar direction in the space. For example, dog and puppy are close together, while skateboard is far away. Now, let's talk about the encoder and decoder blocks, the two main components of a transformer. The encoder reads the input text and creates contextual representation of each token. It uses attention layers to figure out how words relate to each other. For example, in the phrase "the bark of a tree," the encoder understands that bark relates to the tree, not dog. The decoder takes those contextual representation and predicts the next word in the sequence. It also uses attention, but in a slightly different way, looking at the tokens generated so far and deciding which ones matter most for predicting the next token. This process happens one token at a time, building a sentence step by step. The encoder focuses on understanding context, while the decoder focuses on generating coherent output. Together, they make transformers incredibly powerful for tasks like translation, summarization, text generation, and so on. Training a language model starts by breaking text into tokens, small pieces of text that the model can process. For simplicity, you can think of tokens as words, but they can also be subwords, punctuation marks, or even emojis. Each token is assigned to a numeric ID. For example, I might be token 1, herd token 2, and dog token 4. With enough training tags, the vocabulary can grow to thousands or even millions of tokens. Why do we include emojis? Because modern language models need to understand how people communicate today. So during training, emojis are treated as tokens with their own IDs and embeddings, just like words. This tokenization process is the foundation of everything that follows. Once text is broken into tokens, the model can convert them into numeric vectors, learn the relationship between them, and eventually generate meaningful sequences of text, images, or code. Tokens alone don't capture meaning. That is why we create embeddings, vectors that represent tokens in multidimensional space. Each dimension encodes a semantic attribute learning during training. Words used in similar context have embeddings that point in similar directions. Imagine a simple three-dimensional space: forward, back, left, right, up, down. Real models have hundreds of thousands of dimensions. This is what allows them to capture subtle relationship between words. Transformers use attention layers to understand context. In an encoder, attention determines how much each word influences others. In decoder, attention predicts the next token by weighting previous tokens. Here is how it works. The model assigns weights to tokens based on their influence, calculates attention score, and predicts the next token. Multi-head attention repeats this process across different dimensions for richer context. During training, the model compares its predicted tokens to the actual token, calculates the loss, the difference between them, and adjusts weights to minimize that loss. This iterative process is what makes the model smarter over time. When generating text, the model builds one token at a time, using the previous output as input for the next prediction. This is how GPT models create coherent sentences from your prompt. Language models come in two main types: large language models, LLMs, and small language models, SLMs. LLMs like GPT-5 are trained on vast amounts of text and have billions of parameters. They can handle almost any topic but require significant compute power and are harder to fine-tune. SLMs are smaller, trained on focused datasets, and optimized for specific domains. They're faster, easier to customize, and can even run on local devices. Generative AI assistants can sometimes provide buttons or visual tools, but most of the time you will interact with them by typing or even speaking a natural language prompt. The quality of your prompt determines the quality of the response. So, what makes a good prompt? It depends on your tasks, the assistant you're using, and the language model behind it. But there are some proven techniques that can help you get the best results. First, start with a clear goal. Be explicit about what you want the assistant to do. Instead of saying, write something about AI, say, for example, write a 200 words blog post explaining why AI is important for healthcare. Second, provide a source of grounding information. This ensures the response is based on real data, not just general knowledge. Third, add context. If you're asking for a summary, tell the assistant how the audience is or what tone you want. Fourth, set expectation for the format and scope. For example, give me 3 bullet points or write in a formal tone. Finally, iterate. Refine your prompts based on previous responses until you get exactly what you need. Behind the scenes, your prompt isn't sent to the model as is. It's usually augmented with a system message that sets rules for the model, the conversation history to maintain context, and sometimes additional grounding data. The success you have with generative AI depends largely on how well you craft your prompts. This has led to a new discipline called prompt engineering, the art of designing prompts to get the most effective results. Generative AI isn't just about answering questions. It can take actions. These applications are called agents. Agents are designed to perform tasks autonomously, based on your instructions. For example, you could tell an executive assistant agent, book a meeting with my team tomorrow. The agent could check your calendar, find an available time, attach a map for the meeting location, and even book a ride share, all without you lifting a finger. Agents work by combining instruction, your natural language commands, with tools that execute those commands. Tools can include calendar APIs for scheduling, payment gateways for transactions, or CRM system for updating customer records. Modern AI solutions often combine assistants, agents, and orchestration. Orchestration is the process of managing multiple components, language models, data sources, APIs, and workflows, so they work together seamlessly. For example, an orchestration layer might coordinate a language model for understanding your request, a database for retrieving information, and automation tool for completing the task. This combination of intelligence plus action is what makes agents so powerful. They don't just respond, they get things done. Now, let's move into a live demo to see how this concept comes to life. In this demo, we will explore together different agents that works to simplify our life. First agent called Expense Chat Assistant. It's basically a good assistant for our employees or colleagues to know what are the different policies regarding the expenses. When I start a dialogue, I can say, hello, what can you do as the agent? The agent will reply, I can help you with information and guidelines for explain claim. And let's say I want to know how much I can spend on a meal. It will provide me an answer that I'm limited up to $75 for a meal. What's about a taxi? Let's say I'm traveling and I want to know also the info about it. So it's also provide me my limits. Very useful. What is the limit for food? It's also provide me the information here. And let's say I don't know how to submit a claim related. It will answer that I need to send it by mail to expense.contoso.com, and my agent even helped me to submit it on my behalf. And if I enter here what I want to submit, it did send a mail to expense.contoso.com on my behalf, and I don't have nothing more to do. So you saw that it saved and the time for my HR to answer those questions. Also for me, it saves the time to send this mail. The second example of the agent that I want to share with you, it's a recruiter agent. Here, let's say I need to find the right candidate for the job openings that are currently available at my company. And I select first the resume, the CV of my candidate from my database. I can check this resume with the information about Michael, his professional experience, education, and so on. And after that, I can check if Michael is matching well the job openings that I have currently at my company. So I can select the jobs that are currently open and analyze the match between Michael profile and the job. So for example, here it's saying that on 90%, Michael matched this digital marketing specialist job. And also, it's not only provide me the result, but also say me where is potential growth area of my candidate. And even it helps me to write email to my candidate to set up an initial interview and providing him an advice about the skills that Michael could potentially develop. And also what I like about it, it's not only help you to write efficient mail, but also it's provides some recommendation, and I can send straight away email to this candidate via my application. Let's try it with a different job role. For example, for developer, here you see that it's opposite. Michael profile is very different from this job. So if you do change the candidate and select this time Sarah, who is actually a candidate with strong software development background, and we select the full stack developer job opening. Here we have 100% match, everything is in green. And again, the application suggests us to generate a mail to proceed with interview. And here is the mail that I can personalize later and send to Sarah. Very simple tool. Again, very visual. If I select a new candidate, another job, and I click to analyze the match, my AI agent will help me save time on reading thousands and thousands of CV, but also on writing my first initial communications with the candidate. So I hope you enjoy this demo with two different assistants and agents that I show you, and let's come back to our presentation. In this section, we'll focus on getting started with generative AI in Azure. This is where we take the concepts we have learned and apply them using Microsoft enterprise-grade platform for AI development. So what is Azure AI Foundry? Azure AI Foundry is a cloud-based platform designed for AI innovation. It provides a collaborative, pro-code environment with enterprise-grade security, making it the ideal solution for organizations that help to build irresponsibly and at scale. With the Azure AI Foundry, you can explore, build, test, and deploy a solution that are reliable, scalable, and secure, all within a single integrated environment. Projects in Azure AI Foundry are built on Azure resources and serve as foundation for creating and managing generative AI applications and agents. Each project includes access to a comprehensive model catalog featuring generative AI models from leading vendors such as OpenAI, Microsoft, and others. These projects also include the Azure AI Foundry Agent Service, which provides a framework for building agentic solutions that can perform tasks autonomously. In addition, projects come with built-in Azure AI services for language, vision, and information extraction. We'll explore models and agents in this section, while AI services will be covered later in the course. The Azure AI Foundry Model Catalog is your gateway to a vast collection of generative AI models. Here, you can browse models from OpenAI, Microsoft, and other providers, review detailed information and performance metrics, and select the models that best fit your needs. Once you have chosen a model, you can deploy it directly into your Azure AI Foundry project. After deployment, you can test the model in the chat playground within the portal, experimenting with prompts and observing how the model responds. This hands-on testing ensures that the model meets your requirements before you integrate it into your application. Azure AI Foundry also includes the Agent Service, which enables you to create generative AI-powered agents capable of performing complex tasks. When you create an agent, you define its name, specify which generative AI model deployment it should use, and configure the tools it needs to operate effectively. These tools include knowledge tools that give the agent access to data sources and action tools that allow it to perform programmatic tasks such as scheduling meetings or processing transactions. You can also connect multiple agents to work together in a coordinated solution, with each agent performing a specific role. This flexibility allows you to build intelligent, task-oriented solutions that go far beyond simple conversational assistants. Next, I will demonstrate how to create and configure an agent in Azure AI Foundry, showing you how to combine models, tools, and orchestration to deliver real business value. In this demo, we'll explore how to create generative AI solution in Azure AI Foundry portal. So let's first connect to Azure AI Foundry. For it, we'll use ai.azure.com. And when you're connected to the portal, you will see in the middle your recent projects that you use, also documentation about Azure AI Foundry and different settings related to the portal. In the settings, you can change the theme related to the portal, language, and original format. It's nice to adjust it before starting using platform. And also in the documentation part, you'll find all useful information about Azure AI Foundry. Very nice resource for those who are just starting to use Azure AI Foundry solution. If we scroll a bit down, we'll see that we have an opportunity to create agents straight from the main page, as well as you'll find latest models as well as model catalog available from the welcome page of Azure AI Foundry. When I open our model catalog, here you'll see model leaderboards by different criteria like quality of our model, safety of the model, cost of the model, as well as throughput of our model. You can browse leaderboards for more details, as well as we can compare models directly inside of Azure AI Foundry, or just search for the model if you have something specific in mind. In any case, there are 11,359 models available on Azure Foundry, so it's quite nice to have this model benchmark option here if you're new and are not sure about which model to select. You can compare model by selecting for the task that you want to achieve. Is it question answering, math, general knowledge, and so on. And when we look on the right side, all models will be located by different axes here. If I want to change it from cost to latency, the location of the model will be different. So now we see that our models change completely their location on the visual. And also, if I'm interested to compare two specific models here in model catalog, it's possible. I just need to go to my model. Here I pre-selected that I'm looking for model on question answering solutions. I select, for example, or for Mini, and I select the second model, so the GPT-5 Mini, and I see that they're very different by latency, but also very different by cost that provide. And it's very nice resource, this model benchmark, because you not only can compare models, but also have a full list view with a table about each model. Also, as soon as you decided which model you want, you can deploy it. Otherwise, you have also different filters on the model catalog, like collections, industry filters, capabilities, deployment options, tasks that you can do with those models. You see that some tasks actually have not so many models capable to execute them, like image analysis, only 2 models, or image to text, we do have only 6 models. And if you select this filter, you'll see all associated 6 models to this task. You can also filter models by fine-tuning capabilities as well as by licenses. If we clear our filter, and let's now select a model that we are potentially interested about. I have here, if I scroll a bit down, GPT-4.1, why not? When I load this model, we'll see some details about it, the description, key capabilities, different use cases that I can review as well. Very important, the pricing of this model. Benchmark section, just to see how it's different from other models, and again the license link with all useful information. I can also fine-tune this model if I want. When I click on use this model, it will propose me to create a project to work with this model. We call this project Demo AI-900 as our course name. In advanced features, I can find the project name. I can rename Azure AI Foundry resource associated with it. I can check my subscription, region, and resource group, and deploy this model. As soon as model is deployed, we will test it in our chat playground. By default, as soon as deployment passes, you see it's opened me my chat playground. And in chat playground, I can provide to my model some instruction. It will be my meta prompt, so I say to the model how it's supposed to behave. I can add my corporate data to this model, so it's use only my data to answer. I can specify how many past messages I want to include to provide the answer based on how many tokens the model can use to provide me the answer, so it's a maximum amount. And I have 2 nice parameters like temperature and top P. They are basically the creativity and the randomness of my models. They're doing the same stuff, but they're using different algorithms. To explain it better, Here a GitHub page that I really love about it. For example, the question, what did the mouse eat? If the temperature is close to 1, it provides different answer like cookie, pizza, cheese, fondue, and so on. And if it's close to 0, it will answer cheese. So it kind of illustrates well what is temperature and top P about. I can also use parameters as frequency, penalty, and presence penalty. Frequency will decrease the likelihood of repeating the exact same text in a response, while present penalty, it's slightly different because it will increase the likelihood of introducing new topics in a response. So I can play with those parameters and see how they impact the reply of my model. It's not mandatory using them. The most important that before starting using your model, you provide the model instruction and the context. On the left, it will be kind of your meta prompt that the system and assistant will always take in account. So let's start with our chat. I'm planning a trip to Paris in September. Can you help me? Our assistant using GPT-4.1 saying absolutely and provides me a few follow-up questions. So how long I will stay? Let's say 3 days. I'm interested in art. I will travel with friends. I not yet booked my flights and accommodation. And I have something specific. I really want to see Louvre. As soon as I provided it, assistant saying, cool, here your plan for 3 days, including morning, lunch, and afternoon and evening plans. It even provides some links starting straight with the Louvre, suggesting me to book my tickets on the main website. I can also ask something related, like for example, where it's recommended to go for food, and it's providing me the list of food close to Louvre, and also providing some tips about reservation, lunch menu, and the lunchtime in France. And I can even ground my question by providing a link to Wikipedia and asking like, okay, I want to know the history of Paris in very short form, and please provide this information based on specific page. So it's what we also calling grounding. So I told that I want the answer from this page. I can also follow up saying, what 3 places do you recommend to stay in Paris to be close to all these historical attractions that it suggested to me? And here it suggested me 3 different hotels, and I did ask also for reasoning behind, so it's also providing me the reasoning at the end of its reply. I could also ask to make some hierarchy of the place to visit and request top 10 place to visit in Paris, and it's provide me starting by Eiffel Tower, Louvre, Notre Dame. And I have my top 10 sites to see in order of popularity. And if I want, I can also use multimodal content in my chat playground and not only communicate with text, but also attach an image to my request and saying, okay, how to get to this place. And as you can see, I added the image of Eiffel Tower here, and I ask how to get there. So model will analyze the image and will understand that I'm asking about Eiffel Tower and provide me how I can get them by different transportation option like metro, bus, and so on, including some useful links in its reply. As I can use image to communicate with my chat, I can also attach some speech services here to use my voice to communicate with my assistant. And after I can deploy this as a web app or use my endpoint and the code to integrate the solution to my own application. I can extract it in Python or open straight away and VS Code if I want, or just copy the code from here. I have Entra ID authentication as well as key authentication available to me. So there's a lot of interesting information here, starting by deploying the model using Playground, grounding your data, selecting parameters, and testing your chat not only with text but also with images and voice. I hope you enjoyed. Let's come back to our slides. And that brings us to the end of our third session. Today we explored generative AI and what makes it different from other AI models. We learned how language models work, how prompts generate completions, and how AI agents use knowledge and tools to perform actions. We also looked at how to get started with generative AI in Azure using Azure AI Foundry. To recap, generative AI is based on language models that understand semantic relationship between tokens. You interact with these models through prompts which generate response in text, images, or even code. AI agents take this step further by using knowledge and tools to execute tasks autonomously. Azure AI Foundry provides a single platform for AI development, offering resources for models, agents, and orchestration. Its model catalog allows you to choose and deploy the right language model for your solution, and its agent service gives you a framework for creating agentic solutions that can transform workflows. This concludes our third session. To continue your learning journey, explore other videos in this course or visit Microsoft Learn for more resources and hands-on tutorials. Thank you for your time, happy learning, and I hope to see you again. Bye everyone!